Hey there, this is Tony Dubiel again. I'm a technical solutions architect working for Cisco Cloud and Managed Services Organization. If you viewed our first series, our first video of the series, that video was primarily focused on the Intercloud Fabric Business Edition, and we ran through some of the main hybrid cloud use cases for reasons why a customer would potentially leverage our tool set as a method for connecting their private enterprise data center to a public provider cloud. Today we'd like to focus more on the actual underpinnings of Intercloud Fabric Business Edition, such as workload portability. How does that work? How do we convert specific image files and make them available to be imported or exported out of the customer's private cloud to a external provider cloud environment? We can provide a conversion if those environments include heterogeneous types of hypervisors, as well as taking a look under the hood into the actual architecture and components of the solution that are installed on the customer premise to provide them with a control point to broker the external connections to the provider cloud. And we will look at, from a provider perspective, what is under the hood and allowing for infrastructure as a service to provide a secure tenant environment to extend the customer's private cloud into a shared multi-tenant provider infrastructure as a service. From a cloud onboarding perspective, there's several functions that are orchestrated and automated through the Intercloud Fabric Director and Prime Network Service Controller that provide the ability to identify a virtual machine workload, to determine if that workload needs its virtual disk and image format converted, to provide those capabilities, and then ultimately to upload that file to the provider cloud. So this is achieved through API calls from the Intercloud Fabric Director using SSL to the provider cloud. And I would like to now walk you through the process by building out this slide. So the first thing we need to accomplish when exporting a virtual machine or image meaning a template. So if we've put together a template based on a purpose-built guest operating system and application that we'd like to make available in the provider cloud, we would follow this same process, as well as just identifying a running virtual machine to migrate. In that example, obviously we need to shut down the virtual machine. Moving forward, and in the next release of the software, in our Diablo release somewhere in the June timeframe, we will introduce an additional capability to help smooth out that process, to reduce the impact of shutting down the virtual machine, meaning that when we provide a background storage migration, essentially we replicate data, and once the data, meaning the virtual disk file, has been replicated to around 80%, then we would shut down the working virtual machine and run it through the same process. So we would just minimize the amount of time that the virtual machine is down, taking into account how long it takes to upload the file, the configuration file of the virtual machine that has been converted to the provider format, as well as the virtual disk file and the conversion of the file and upload into the provider as well. We can reduce that amount of time. Again, that would be variable depending on the amount of bandwidth and the type of connection, whether it be internet or private connection, such as a direct connect, all of those variables would influence how long it would take to migrate a workload. With background storage migration, it's not a live migration, but it's a it's a near live migration in that there's minimal downtime. So if we look at a virtual machine manager, in this example, vCenter, and if we were to integrate Intercloud Fabric Director into a vCenter such that we would have visibility into all of the virtual machines that reside in the virtual data center as part of that domain, we can identify a virtual machine. Through the tool set, we would shut down the virtual machine, and then we would start this process. Depending on the file format, we would convert or not convert depending on the target provider cloud and what type of hypervisor is running on that side. Currently, we can support BMDK disk files from VMware, OVA templates, ISO, RAW images from KVM, and again, we also more recently have Microsoft Hyper-V as well. The next step is, regardless of the file type, we need to install a driver to create an agent that runs in the guest operating system. What we're doing is we're installing essentially a VPN client. This allows for the virtual machine to maintain the private IP address and subnet as it existed in the customer's private data center. Now we have the VNIC available to act as a client as we power up this virtual machine in the provider cloud. It's allocated a virtual NIC that resides in the hypervisor and port group of the provider cloud environment that is made available for the tenant. On top of that VNIC, we have a VPN client that is running the customer's private IP address. So we're leveraging the tenant private IP address from the provider as the virtual and physical network to communicate in and out of that tenant environment, which is really an overlay constructed through these VPN clients that connect every virtual machine together on the provider cloud side, as well as every virtual machine to the gateway and optional router or firewall that also has the driver and agent installed in those virtual machines that would function as a virtual appliance, providing network capabilities on the provider cloud side. We'll unpack that a little bit more in subsequent slides, but for now we'll stay more focused on just the workload mobility piece. So once we've converted to the target provider cloud, and depending on again what hypervisor is running in their environment, we may have converted to AMI if we're moving a workload into Amazon, VHD for Azure, and then obviously we can maintain VMDK or an OVA file if the target provider is a VMware hypervisor shop on on that side, on the provider cloud side of the connection. Okay, so here's the real poop, if you will. What do we have under the Komodo? What is the secret sauce, and how does it work? So this slide represents the Intercloud Fabric architecture. We will look at the Intercloud Fabric Business Edition side. That's everything that is represented over here on the left-hand side of this, everything here. And we will also take a look at the Intercloud Fabric Provider Platform, which is an API gateway that enables functionality for Intercloud Fabric on the provider cloud side of the connection. And then we have the ICF link, which is a secure VPN tunnel with layer 2 LAN extensions leveraging 802.1q trunking and AES encryption between the customer's private cloud in the provider cloud. So let's take a look at some of the prerequisites. Again, if you had attended session 1, we talked about the solution is delivered as a software stack. If in the example of VMware, it's OVA files are installed, and similar along those lines, we have templates for KVM, OpenStack, Microsoft Hyper-V. In all of those examples, the prerequisite and the requirement is that in order for our software appliance to function, we need VLAN connectivity, we need port groups, and 802.1q available on those uplinks from the host hypervisor to the physical infrastructure and network that provides for northbound connectivity, either to a private connection to the cloud provider or a over-the-top public internet connection. In the example of VMware, we support vSwitch, distributed virtual switch, or Cisco Nexus 1KV switch. We support any of those. None of them are required. Nexus 1KV functionality has been ported into the Intercloud Fabric tool set, but it's not the Nexus 1KV product. So what we've done there, and as I build out this slide, you'll see the difference is that instead of installing a VEM, a virtual Ethernet module, into a host, in VMware that would be an ESXi host, we provide a virtual Ethernet module in a virtual machine. So essentially it's a virtual appliance that requires a port group to connect vNICs, as well as a trunk, to allow multiple VLANs, tagged VLANs, so that way when we create our tunnel, we can span the customer's VLANs that we select into the provider cloud. So at a minimum, we need 802.1q, a virtual switch. From a server perspective, obviously we recommend UCS servers, but this is a software solution that is agnostic in that Intercloud Fabric Director and the other components can be installed on any server with suitable hardware from a CPU, memory, and storage perspective. And the second piece is that we need to have network reachability to the virtual machine manager, vCenter as an example. We need a service level account. We configure that as part of a wizard, and that would provide visibility and would give us functionality, roles-based access from the Intercloud Fabric Director to identify virtual machines, and then to be able to bring them into a virtual data center that has been provisioned to connect to a cloud provider. And I'll walk you through some of those steps, as well as in a future demo, we'll go through each one of those steps actually using the wizards that are included in the Intercloud Fabric Director product. So what you can see here, this is the existing environment. We have a virtual machine that is running Windows. It has a VNIC that's installed from a port group that's a part of a virtual switch as it exists in VMware. On a 192.168.10.10 is the host address, so that's the VLAN and subnet is different than a web server, which is on another subnet and a different VLAN with a 192.168.20.10 address. And then we have a database, a SQL database that is virtualized as a virtual machine with an address of 192.168.30.10. So all three of these tiers of a three-tiered application are on separate subnets and separate VLANs. And the virtual machine manager, the vCenter, is on a fourth VLAN, which is 192.168.100 subnet. So this is the existing environment. So the first thing that needs to happen is we need to install the OVAs of the Intercloud Fabric Business Edition. So it's a software suite that includes really three virtual appliances. So one of the virtual appliances is actually two containers. So there's two separate processes running in the same virtual machine. One of those being the Intercloud Fabric Director, which happens to be the IT console that is provided to the admin as well as the end user, which is typically someone, an application owner or a developer or someone else from the IT department that logs in to gain access to cloud resources that are brokered through this IT console. The Prime Network Service Controller is a component that the customer typically doesn't configure, but is orchestrated through workflows that are initiated in the Intercloud Fabric Director. So the Prime Network Service Controller provides functions such as making a router available in the provider cloud, configuring that router, a firewall, an optional firewall can be delivered in the provider cloud. It's also the component that would provide the conversion of images, as part of migrating that virtual machine to the provider cloud. So the Prime Network Service Controller is providing a lot of functionality, but it's orchestrated through Intercloud Fabric, which is one of the benefits, is that the customer doesn't have to worry about all of the details of configuration. They provide policies and pools of resources like their IP addresses, which can be allocated to templates, security policies, and other similar policies that are implemented by the Intercloud Fabric Director as as they're required or consumed as part of a catalog. And we'll see that in the demo as well. You'll see the catalog. You'll see what the user interface provides versus the administrative console, which provides more granularity and the ability to create these policies that are used as part of orchestrating the connection to the cloud, and then for uploading virtual appliances into the cloud to build out that tenant environment, which is really an overlay on top of the infrastructure as a service as it exists in the provider cloud. So the next thing here is, once we identify a public cloud, we need to build out a Intercloud, cloud connection to that provider. And in order to do that, we need an account. So, that's a prerequisite. The customer needs to establish an account. We need to leverage their key. Depending on the provider, the key and identity management is a bit different, but in any case, we need those credentials, right? So we need those credentials so we can configure them, as part of a wizard for building the cloud connection. Once we have those credentials and we start to work through the wizard, a part of that configuration is an API call. So we authenticate. There's an API call to request resources. So what are these resources? It's basically infrastructure as a service. Compute resources, memory, and storage. I mentioned block storage on the previous slide. We need those resources in order to import our templates, and then to power on these images to leverage them as virtual appliances in the provider cloud, and then to ultimately either migrate workloads or to spin up, instantiate and spawn new instances or copies of applications and other types of workloads in this tenant environment. So we need to implement on the customer side the switching and the VPN capabilities. So as part of that, we have the Intercloud Extender. The Intercloud Extender is that virtual appliance that represents a virtual Ethernet module that requires that port group, that has that 802.1q trunk, so that way we can span VLANs and create this secure AES encrypted layer 4 SSL tunnel between the provider cloud and the customer's private cloud. So we'll request resources. That network is built based off of the tenant's private IP addressing that resides behind a tenant router in the provider cloud. That router could be a physical router, it could be a virtual router. It really doesn't matter to us, other than the tenant does have some form of a gateway, because provider clouds offer a public IP to a virtual machine that's consumed as part of infrastructure as a service. So that public IP is allocated by the provider, and they provide a NAT functionality, so that way there's a tenant private IP, on a RFC 1948 private IP address, as well as a public IP. The third IP is that abstraction of the VNIC based off of installing that driver to create a VPN client, as part of an agent. So that's where we maintain the customer's private IP address. So really, there's three IPs. There's one VNIC with at a minimum one VNIC with the tenant private IP that is NATed by a router. So a public IP that is exposed on the front end, and then the third IP is the VPN client as it exists. So the next thing that we need to do is we're building out that tenant environment to create a cluster of services that provide value to the virtual machines that are migrating, because now those services are offered as part of a secure tenant environment without the need to configure or to consume these types of services from the provider cloud. Because in this case, the objective here is to extend the private cloud into the public cloud provider as if it were a single logical data center, as opposed to setting up a public cloud IaaS where you're isolating an application, but your dependency is on services that are consumed only by the provider cloud. So this way we're able to benefit from our own services and then to consume services as needed from the provider cloud. But at the end of the day, for the most part, we're just leveraging them for infrastructure as a service, hardware and software resources. And we maintain as a customer control of the virtual appliances that we import into the provider cloud. So this is an example of the switching component, the head end for the site-to-site VPN, SSL VPN with layer 2 LAN extensions, and an optional firewall that can protect a full layer 4 through 7 firewall, stateful firewall that can protect between virtual machines and between VLANs and tiers of virtual data centers that we provision in the provider cloud. So once we import the ICS switch, the Intercloud switch, which also functions as a VEM, a virtual Ethernet module that would integrate into the tenant private IP on the provider cloud, we can bring up the tunnel. So again, the tunnel is a layer 4 tunnel, AES encrypted with layer 2 LAN extension. We can extend layer 2 environment as well as localize the routing between those VLANs in the provider cloud. So in order to do that, we also would leverage the routing capability. This is an integrated gateway, which means that it's a layer 2 device as well as the VPN head end, and functions as a layer 3 gateway to route between VLANs. In Azure, that's the model that's currently used. There's also an option for a CSR light router. So it has limited functionality than a full-blown CSR 1000V, but that's what we provide in AWS, is a separate router to function as the gateway. So depending on which provider, it may be integrated, it may be a separate device. The benefit of the integrated gateway is obviously the footprint. So it's a single virtual machine. Depending on the throughput, then that would determine the sizing, the instance type, the actual flavor of a virtual machine and the consumption of virtual CPU and memory. That's the types of resources that you need to increase throughput. So to connect to a provider cloud, we're talking generally 100 a meg, 1 gig, and even the ability to consume a 10 gig connection. But then that would be a significant footprint of a virtual machine and consumption, from a hypervisor host on the provider cloud side, and that infrastructure as a service, and that cost would be high, depending on the provider cloud and what their metered service looks like from a network and compute perspective. So once we have the tunnel, we can identify a virtual machine, and we can execute on that process that's automated and orchestrated from the previous slide, giving us the ability to migrate a virtual machine into the provider cloud and maintain that private IP address, in addition to a VNIC that is installed that represents the private tenant IP, so that way we have reachability and routing that is localized in a part of the provider cloud, which gives the customer options to subscribe to services or to connect to DR services between availability zones that are routable in the provider cloud. There's options there for that type of connectivity. Another aspect that's not depicted on this slide is that we can introduce HA, in that we can provide dual tunnels with ICS switches and ICX switches, respectively, on both sides that have HA, keep alives, between them. So if there's a failure, it's an active standby configuration, and we can have a second set of VPN headend and VEM module to provide layer 2 services on the provider cloud and on the customer side of the cloud, to avoid failures. Obviously, those HA pairs need to reside within the same availability zone from the provider because they need to be reachable for the keep alives. But you can certainly connect a separate set of tunnels to another data center or region in the provider cloud, with a separate set of tenant IP addresses if you want geographical separation and redundancy from the provider cloud side of this. So the next thing is that we can introduce templates, upload templates into Intercloud Fabric Director, as I mentioned before, and we can upload those templates into the provider cloud. So once they're uploaded, it's a very quick turnaround time to instantiate, to spawn an image in the provider cloud. But initially, we need to upload, the entire image file, depending on how large that is, would influence how long it would take to upload and import into the provider cloud. Once it's there, it's a similar process. There's a private IP address based on a pool of IPs that needs to be provided as part of the network policy in the Intercloud Fabric Director. So we would just allocate IPs, similar to DHCP, from our own customer private IP addressing, and then a tenant IP address would be allocated as part of a VNIC from the provider cloud. So in this case, 10.200.20.2. These are in separate subnets on the provider cloud because we can carve it out that way. On the provider cloud, we can have multiple subnets, or VPCs is the nomenclature we use in AWS. Similar situation in Azure. We can have multiple private subnets. But the idea here is, because we provide this overlay, the customer benefits by being able to simplify the provider cloud network infrastructure. There's really no need to carve up anything because we're providing security and segregation through encryption as part of building the shell, or what we call the bubble. And then everything outside of that really doesn't need any complexity other than if we want to connect to multiple availability zones. And obviously we have additional subnets that exist in another, geographically exist somewhere else in that provider cloud. Did somebody say bubble? What the heck is a bubble? Well, the bubble is our secure shell. This is how we abstract infrastructure as a service, but create an overlay that represents a tenant clustered environment that includes multiple services, firewall, routing, load balancing, etc. So if we look at the shell, the magic here is that we maintain reachability from the provider network that's been allocated for a tenant, and then we have that that VNIC representation through the driver and the agent that allows for a VPN client. But at the end of the day, this is an abstraction, it's an overlay. We're really using, this is the virtual VNIC that's providing transport, and this VNIC is riding over top of that as a VPN client. I liken this to a split tunnel. You have an IP address that's a part of your VPN client, and you're leveraging your own public internet access for that VPN client. All traffic that needs to go to the private IPs is directed into the tunnel, and then other traffic would use the local area network to connect, which would be a similar situation in this provider tenant network. Additional security features are provided as part of the secure shell. We talked about the site-to-site connectivity, the AES encryption, the layer 4 tunnel, the SSL tunnel that provides the ability to span layer 2 VLANs using 802.1q trunking. There's also an authentication as part of this process where every VM is authenticated either through a self-signed certificate or you can import a PKI certificate to authenticate the VM as well as provide the encrypted tunnel connection. So that's important because we can prevent tampering, and it's a known good image that's not tampered with in transit or when stored in the provider cloud. There's also the ability to leverage group-based firewall policies as they existed in the customer private data center. So if you're a customer and you happen to be using Cisco BSGs, or our virtual firewall appliances, those policies can migrate with a virtual machine based off of policies that are configured as part of groups in the Intercloud Fabric director. When a virtual machine migrates to the provider cloud, if the firewall has been instantiated on that side, then those policies would migrate along with the virtual machine. So it's an easy way of maintaining the same firewall policies regardless of where the virtual machine resides. It's the same network, it should have the same security policies. As it migrates into a provider cloud, your private cloud has been extended to the public cloud within this shell, so everything should work the same as it existed on your private data center. Benefit for an application is it communicates to all these other virtual machines and services as if they were on the same local area network, which means translates to not having to convert anything that is stateful as part of a traditional application stack, which is a benefit of being able to migrate traditional workloads into the cloud, where cloud native architectures benefit from being able to scale out and by leveraging other API services from the application to the actual cloud operating system. For applications that don't have those types of capabilities, then this is a great way of making those applications more cloudy but maintaining security through this secure shell and bubble. The other aspect of this is third-party support of encrypting the data at rest. So we've been talking about site-to-site encryption and VM-to-VM encryption in the provider cloud side of the tenant environment. We can also support through a third-party SafeNet and other best-of-breed vendors. We're building interoperability to allow for those third-party solutions to encrypt the data at rest. So those VMDK files that are stored in block storage as part of a marketplace offering in AWS and other cloud providers, these third-party solutions can provide encryption. Intercloud Fabric is supporting interoperability in the ability to implement their virtual appliances on-prem for key management. So these keys can be stored in the customer premise, in the customer's data center, to encrypt the storage on the provider cloud side. So that way, if there is a regulatory requirement to maintain key management on-premise, in full control of the customer, then there's an option for that as well. Well, that wraps up the deep dive into what's under the hood and how Intercloud Fabric Business Edition works as a software stack and the functionality on the customer side as well as on the provider side. So thank you for your attention and your time, and stay tuned for some live demos, and I look forward to your attendance in Intercloud Fabric Business Edition demo. Multiple different demos for different use cases. Stay tuned, and I look forward to talking to you later.